This video will cover the following angle relationships: adjacent angles and non-adjacent, linear pairs, vertical angles, complementary angles, and supplementary angles. First up, complementary angles are two angles whose measures have a sum of 90 degrees. They might be right next to each other, like 1 and 2, but they might be separate, like 3 and 4. Still, both are complementary. Supplementary, similar idea, but this time they add up to 180. So 5 and 6 right next to each other, or 7 and 8 detached, still add up to 180. So when we say that angles are right next to each other, a more mathematical and precise term is that they are adjacent. And the definition of adjacent angles, angles that share a common side and vertex. So angle 1 and 2 are adjacent, for example, or 2 and 3, or 3 and 4, or 4 and 5. They share a vertex and one side. Vertical angles are two non-adjacent angles formed by two intersecting lines. So consider these two lines that I've shaded in green. Angles 1 and 3 are considered vertical angles, and they're equal to each other. Angles 2 and, well, if you combine the areas of 4 and 5 together, are equal to each other, where I put the blue lines. Those are considered vertical angles. There can be multiple sets of vertical angles within the same diagram. The only criteria is when you have two lines that cross, the opposite angles are equal. Lastly, linear pairs. These are two adjacent angles, so they're next to each other, that form a straight angle. A straight angle is 180 degrees. So these angles are also considered supplementary because they add up to 180. But they have to be next to each other. The supplement of angle Z is an angle that if you add it to 42.1, which is Z's measure, you get 180. So I'm going to put an S here for supplement, just as an unknown, and I can subtract 42.1 from both sides to find my answer. The supplement of Z is 137.9 degrees. Same idea. This angle, which measure is at 8x minus 20 degrees, I add something to it and I get 90. So I'll stick in a C here for complement. I'm not going to be able to solve this because of the variable, but if I move everything over to the other side by adding 20 and then subtracting 8x, the complement can be 110 minus 8x degrees. Sometimes we might have to turn a phrase into an expression. 12 degrees less than 3 times its supplement. Here, if I consider the supplement as x degrees, 12 less than 3 times its supplement can be expressed as 3x minus 12. Combine like terms, add 12 to both sides, x equals 48. They want to know this angle over here, so I can plug in 48 for x. 3 times 48 minus 12. My final answer is 132 degrees. If we say that an angle is its own complement, we're saying that angle plus itself is equal to 90 degrees. So if 2x is equal to 90, 1x is equal to 45. If we want to find the supplement, then we're saying 45 plus what is equal to 180. If I subtract 45 from both sides, I'm going to find that the supplement, we'll call that S for supplement, is equal to 135 degrees. In number 5, these two angles are complementary, which means if I add them together, I get 90 degrees. I can combine like terms, subtract 2 from both sides, divide both sides by 8, and I get that x is equal to 11. They want to know what the measure is for both of these angles, so I just go back and plug that in to both cases and find my solutions. So for both expressions, I'm going to plug in 11 for x. Angle DEF is going to be 29 degrees, and angle FEG is going to be 61 degrees. Number 6 is set up very similarly to number 5, just they're equal to 180 because they're supplementary. I combine like terms, subtract 10 from both sides, and divide by 17 to find x is equal to 10. I can plug in 10 for x for both of these angles, and angle DEF is going to be equal to 91 degrees, where angle FEG is going to be equal to 89 degrees. In number 7, these angles are adjacent, meaning they share a vertex and one side. It's going to be this one. They are also a linear pair, because they are adjacent, and if I was to add them together, they equal 180. Number 8, these angles are adjacent. They share a vertex and one common side. They are not a linear pair, though, because they don't add up to 180. In number 9, these angles are not adjacent. Though they share a vertex, they do not share a common side. For number 10, we're looking for a pair of vertical angles. We have two choices. Angle 1 and 6 would work. Also, angle 5 and 2. So I'll write it out like that. There are many examples of linear pairs in this diagram. 3 and 4 are adjacent angles that add up to 180. 1 and 5 would work, or 6 and 2. And I could also use 1 and 2, or 5 and 6. So lots of choices there. I'm going to write down angles 3 and 4. Next up, an angle adjacent to angle 4, so it shares a vertex and has a common side. That would be angle 3. So for number 13, they tell us that angle 2 is 45 degrees, and they tell us that angle 3 is 90 degrees. So can we figure out the rest? Well, 5 is a vertical angle with 2, so they're equal, so that one's 45 degrees also. Since 3 and 4 are a linear pair, they have to add up to 180, so 90 and 90. Since 1 and 2 are linear pairs, these are going to be 135 degrees, and 135 degrees over here. I could do that by vertical angle or setting another linear pair.